Welcome to the next unit on combining functions. In this lesson, we are going to look at combining functions graphically, and the next lesson we'll look at combining functions algebraically. So when we're combining functions, we can sketch the graphs of functions that are the sum, the difference, product, or quotient of two functions. Most of the time, we're only going to do sum and the difference, because that is the most common one for the final exam and the provincial exam. But I'll show you how to do all four. We're going to be given two functions. One's called f of x, the other called g of x. And then when we combine them, we're going to combine their y values, but leave the x values the same. So if we want to add f of x and g of x, all we're doing is adding up those y values. It's important to get a few points from our graph. So we can look at our g of x graph and look at our f of x graph and pick up a few points from there. So from f of x, it looks like we have the point 0, 0. And then we have the point 1, 0.5, then 2, 1, and 2.5, 1.25. We can even approximate this one a bit, which could be 2.75 and 1.4, and then lastly 3, 0, or 3, 1.5. So this one here we're probably not going to use because we're approximating too much, but it is also the intersection point between f of x and g of x, so this one we will take a note of and maybe use later. Now I'm going to look at the g of x graph. We have point at 0, 0. Then I'm going to look at 1, and we have a point at 1, 4. A 1.5, we have a y value of 4.5. Then 2, 4. 2.5, 2.5. And lastly, 3, 0. The reason why I want to collect a few points is we're going to add those y values together to create our combined graph. So if we look at our f of x plus g of x, we're going to keep our x values the same, but add up our y values. So we're going to use x equals 0, 1. We could also do 2, 2.5, and 3. So if we look at our y values for x, f of x has a y value of 0 at x equals 0. So we're looking at here, so that would be 0 plus 0, and then 0.5 times 4 plus 4, then 4.5 plus 1, and at 2.5 we'll do 1.25 plus 4, and lastly 0 plus 1.5, which is 1.5. Then we will graph these points. So we have a point at 0, 0, 1, 4.5, 2, 5.5, and then at 2.5 we'll have 5.25, and then at 3, 1.5. and we'll combine or connect our points, which takes on a shape like this. We are done. We do need to consider the end behavior of our combined graph. If we take a look at this corner here, we have a negative value plus a negative value, which means that we're going to have a more negative value. So I'm going to go down and put an arrow there then. And if we look at the other side, we have a negative value that's going very steep plus a positive value. It looks like eventually we are just going towards the negative direction because we have a very large negative number minus a smaller, or added to a very small positive number. So I'm going to add a little arrow there as well. For our next one, f of x minus g of x, we're going to create the table of values, and now we're going to subtract. Remember to do f of x minus g of x, the order does matter. So the f of x y value minus the g of x value. And we'll do it for 0, 1, 2, 2.5, and 3. Okay, so for 0, we're going to have 0 minus 0, which is just 0. The f of x value at x equals 1 is 0.5 minus 4, so that's negative 3.5. Then we have 1 minus 4.5. Sorry, 1 minus 4, which is just 3. Then we have 1.25 minus 2.5, which is negative 1.25. Then lastly, 1.5 minus 0 is 1.5. And we'll graph these points. Okay, so our first point's at 0, 0, then negative 3.5, then 2, negative 3, then negative 1.25 at 2.5, and then 3, 1.5. Looks kind of like this. And then on the other side, so looking at the end behavior on our left side, we have a small negative value for f of x subtracted by a large negative value, which means that this will become a positive large value because negative times a negative. So a small negative value plus a large positive value, this is going to go in the positive direction then. Moving on to the f of x times g of x, same sort of thing. We can create table values and we're just going to multiply our x and y values. So we're going to do a table of values, and now we're going to multiply our y values together. So x is 0. We have 0 times 0, which is 0. And then for x equals 1, we have 4 times 0.5, which is 2. Then the next one, for 2, we have 4 times 1, which is 4. At 2.5, we have 2.5 times 1.25, and we can just use this calculator for now. You're going to get questions where you don't need to do that though. This will be 3.125. Then lastly for 3, that's going to be 0. So we're going to go ahead and graph the following points that we have. Okay, so the point at 0, 0, 1, 2, 2, 4, 2.5, 3.125, and then 3, 0. So I'm going to connect those points. And then I need to think about the end behavior. So looking over here, we have a negative times a negative, which becomes a positive. So on this side, they're going to go up in the positive direction. Then we have a negative times a positive, which is still negative. So on the right side, I'm going down. As for the next one, I wouldn't worry about this because we'll never really see it ever in any assessments or anything like that. But the same principle would apply if you do f of x divided by g of x. You would divide your y values, and whenever you divide by 0, this does create an asymptote. So keep that in mind. Then the next part is we're going to take the graph that was given to us for those two functions and solve for x for whenever f of x is equal to g of x. That means the y value of f of x is equal to the y value of g of x. You're going to look at the intersection point. And when you're reading the intersection points, because we're solving for x, do not state anything about y. You're just going to state your answer in x. There may be more than one intersection point. So looking back at our graph here, we have an intersection point here where g of x and f of x meet, and we have another one. So we have 2 intersection points, which means we have 2 answers. X equals 0 and x equals 2.75. And that would be your answer. Remember to state it in terms of x only. Do not give us the point. Now I want you to try this on your own, and then when you're ready, press play for the solution. Okay, so the first thing I would do here is pick some points from f of x and g of x. So for f of x, we have a linear line. I'm just going to pick a few. I'll pick this one, this one, this one, this one, and that one. So we have -1, 5, 0, 4, 1, 3, 4, 0, and 5, -1. Then we'll do the same thing, but for g of x. I'll pick this one, this one, this one, this one, and that one. So that's -1, -5, 0, -6, 1, -5, 4, -2, and 5, -1. Then I'll create my table values for these combined functions. So for f of x plus g of x, I'm keeping my x value the same, but I'm going to add our y values. So we have 5 plus -5, which is 0. Then we have 0, our y value is going to be 4 plus -6, which is -2. For 1, we have 3 plus -5, which is -2. For 4, we have -2, and lastly for 5, -1 plus -1 is -2. So we can go ahead and graph this. The point at -1, 0, 0, -2, 1, -2, 2, -2, 4, -2, and 5, -2. We're going to connect these points. And then we're going to extend each side. We know that they're going to continue this way because here our slopes are the same. So if you keep combining these here, we're going to always get -2. And on the other side, if we keep combining these, we're just going to get larger and larger numbers. Moving on to the next one, we have f of x minus g of x. We're going to start off by writing a table of values, keeping our x values the same. Okay, order does matter because we're subtracting. So we'll have 5 minus a -5, which is 10. 4 minus -6, which is 10. 3 minus -5, which is 8. For x equals 4, we have 0 minus -2, which is +2. Then lastly, -1 minus -1 is 0. So I'm going to go ahead and graph these points. And then I'll go up by 2s. Then we'll graph these points, -1, 10, 0, 10, 1, 8, 4, 2, 5, 0. And connect these points and then extend them a bit. If you want to, you can find your points for x equals -2 and x equals 6, but the pattern will continue. Lastly, to find the solutions of f of x equals g of x, we just need to find our intersection points. In this case, we only have one. It's located over here. If you look at those coordinates, it's 5, -1, but remember we only want to find the x value of the intersection, which is going to be x equals 5.